Hi everyone, welcome back to our channel. Today we are going to find the equivalent resistance between the terminals X and Y for the resistive network shown below. So this is a confusing question and very simple question. The red color one are in delta and the black color were in star. So first I'm converting the star to an delta. Let's try to mark the nodes. So to overcome the confusion, A, B and here I have the C. So this is in star. Okay. So one branch, second branch, third branch. The values are 2 ohm, 2 ohm as well as 2 ohm. So I want to convert this star into an delta first. Then the problem becomes simplified. You can do in by reverse. So the red color are in delta. You can convert that delta into an star also. That you can do in the second method. So first I'm solving it by method 1, which I'm very convenient. Okay. So now the black color are there. I want to transform into red. Okay. So I'm going to get a red color resistor in this part and one more red color resistor in this part. So let's try to do one by one, then you'll get a clarity, or if any confusion is there also you can overcome. Okay. So this red color resistor I need to find out. So how to find this red color resistor is so very simple. So the red color resistor is connected between which two black color resistor? One is 2 and 2. So you have to write down it as 2 plus 2 plus product of these two. So 2 into 2 and these two completed. What is the remaining resistor divided by 2? So that's how we find this red color unknown resistor. Again, I want to find out this unknown resistor. How to find this unknown resistor is this red color resistor is connected between two black color resistor which are known. So what is the first value? 2 and another value is 2. The product of these two, which is nothing but 2 into 2 divided by, so what is the remaining resistor is nothing but 2. So there is this value. And how to find this unknown resistor branch? Okay. So here this red color resistor is connected between this black color and this black color. So first you have to write down first black color is 2 and another one is 2 and the product of 2, which is 2 into 2 divided by the remaining is 2. So here you can see here this is an equivalent star to delta conversion with equal values. Just you can see here I will say the concept later. So 2 plus 2 plus it is nothing but 6 ohms. This is also how much? 6 ohm. This is also how much? 6 ohm. If a star of equal values like 2 ohms each, whenever what will be the resistance of each branch is it is multiplied 3 times. Therefore the ultimate resistance in a delta is how much? 6 ohm. So star we are converting into delta, where each branch resistance is 2 ohm, 2 ohm, 2 ohm. Ultimately each branch is scaled by how many times? 3 times, which constitute each branch resistance as 6 ohm. Okay. So it's a simple technique. If you know this technique you can solve the problem. Very simple. Now I'm going to redraw it. Okay. So I'm going to have the A node and I'm going to have B node. So now already between A and B I'm having 5 ohm and I'm going to have C node as well as D node, and here I'm going to already I'm having 10 ohm and here I'm already having one more 10 ohm. So this converted delta I'm drawing in another color to make the things color. Between A and B, what is the value got? 6. Okay. So here we are going to get a 6 ohm resistor. Okay. So here you are going to get a 6 ohm resistor. This is 6 ohm resistor. Already you have 5 ohm resistor also. Okay. And here between B and D you are having additional 6 ohm resistor. So this also I'm drawing. So you have an additional black resistor of 6 ohm. So and next one between A and C also you are having one more additional resistor. So I'm going to draw this as 6 ohm. So due to some software issues, this has gone, no issue, you rewrite it again. So here we are going to have 5 ohm. You can see here these 5 and 6 are connected in parallel. Okay, so now resultantly if you redraw it, so here you are going to here we are going to have a, as well as here you are going to get one resistor, and this is B value, and between this C and D also you are going to have remaining two branches. This is one branch, this is another branch. You can see here overally these two are connected in parallel, these two are connected in parallel, these two are connected in parallel. Whenever they are connected in parallel, it's nothing but product of resistance divided by sum of resistance. When you perform the product, this is 5 into 6 divided by 5 plus 6. Okay, so this branch value is how much? One is 10, one is 6. 10 into 6 divided by 10 plus 6, coming to this value. This is also same, 10 into 6 divided by 10 plus 6. Okay, so this is between A as well as D. So now you can see here, now we had gotten star. Okay, sorry, delta. So now between this I'm drawing in a simplified version, A, C, D. When you solve it, you're going to get it this as uh, 3.75 ohms. This is 3.75 ohms, and you have another branch here, and you have another branch here. This value after solving you are going to get 2.72 ohm. This is 3.75 ohm. So I require the resistance between R, X, Y. So what we are going to do is, you can see here the current is entering and the current gets divided across these two branches. But the current which flows in this branch and the same current is flowing, I can say these two are again connected in series. Okay, whenever they are connected in series, then the resultant is like this. So this is 3.75 ohms, and between A and CD we are going to get one more resistor, which is nothing but the sum of these two. So sum of 2.72 plus 3.75, if you add, then you are going to get 6.47 ohms. Okay, and again the resultant you can see here, this is between X and Y. So we require the resistance between R, X, Y. So these two branches, current is entering, current is dividing. These two branches are again connected in parallel. So these two are again connected in parallel. So whenever these two are connected in parallel, then you are going to get a single resistor between X terminal and Y terminal, which is nothing but R, X, Y. Okay, so then this value is 3.75 multiplied with 6.47 divided by 3.75 plus 6.47. So product of resistance by sum of resistance. Then the value of Rxy after solving, if you solve it, then you are going to get it as 2.374 ohms is the Rxy between the terminals Rxy. So this is the procedure of solving. So I just used one method. I converted this black star into an delta. I inserted the same delta in this delta. So therefore the elements are in parallel. So whenever these are in parallel, I had got an one value. Okay. So this is the resultant values what I had got by doing parallel of these two. So after performing, you can see here these two branches are connected in series, or connected in series. The resultant is nothing but the sum. This is 3.75. These two branches are again connected in parallel. Therefore, you are going to get 2.37. Hope you are able to understand the problem. You can solve it by method 2 also. It's nothing but, so this is the given network, the red color is an delta. Convert the delta, I mean this red color, 5, 10, 10, or in which form? Delta form. Convert this delta into an star. Okay, so there also you're going to get a star. This same process, you'll also get the same answer. Verify yourself and hope you'll also get the same 2.37. So if you feel my explanation is good, please give a like to the video, and if you are feeling to share with your friends, which will also help your students to understand better, share with your friends. And if you have any doubts, let me know in comment section. And if you're watching the channel for the first time, subscribe the channel with the name KV Tulasiram. And this is a free channel. Kindly support this channel. This is a free channel for the development of students as well as faculty. Yours obediently from. We'll meet in the next video.